Hello, this will be the start of a three-part series of how to design and build your own small model rocket. In this first video, we will be looking at how rockets work and their components. In the second video, we will be reviewing the OpenRocket software and how we can utilize it to design a rocket. In the third video, we will be making our own rocket from scratch. First, let us look at how a model rocket works. We begin on the ground with the rocket setup on a launch stand attached to a guide rail. An electric igniter sparks to start the combustion of the engine. From here, the rocket flies off of the guardrail, propelled by hot gases that exit the bottom of the rocket. This follows Newton's third law that for every force, there is an equal and opposite force. The upward force opposite of the hot gases is what we call thrust, and it propels the rocket upwards. Once the engine is done burning, this thrust force no longer is present on the rocket. Now, the rocket acts as a projectile. Similar to how a ball that is thrown upward works, it'll slow down until it changes direction back downward to Earth. This point of change in direction will be the max height the rocket achieves, also known as apogee. As close to apogee as possible, we will want the separation of the nose cone and body tube to occur to allow for the parachute to deploy. This occurs as the engine finishes its burn. A small charge pressurizes the inside of the rocket, pushing off the nose cone from the body tube. This allows for the parachute to deploy, creating a safe descent for future launches. Now we will look at the components of a model rocket. First is the engine. This is the power source of the rocket. It provides thrust to propel it upwards. Then we have the engine mount. This holds the engine in place during flight, as well as connecting it to the body tube. Next, the body tube. This is the main cylinder of the rocket. It holds everything together. Attached to the body tube are the fins. They provide stability in flight and keep the rocket flying straight. On top of the body tube is the nose cone. This is the top of the rocket. Its shape reduces air resistance that the rocket faces, allowing for higher and straighter flights. Launch lugs are attached to the side of the body tube. These allow for the rocket to follow the guide rail at launch. Then we have the parachute and shock cord. These allow for the safe descent of the rocket. The shock cord is connected to both sections of the rocket to hold it together after separation. The parachute is attached to the shock cord.